Okay. So the next thing that we are going to do, now we have all this information. Okay. The next thing we are going to do is we are going to apply static analysis first. Okay. We are going to apply static analysis. I mean, you can do elastic deformation. Okay. I'm not saying that you can't. You can carry out elastic deformation also, but let's do static analysis first. Okay. Let's do static analysis first. So using so we're going to apply static analysis. Hold on, I need to go lower because, by the way, AY has something over here. Okay, so this is AY, and we have AX. Some of you will say, Eugene, why AX direction? AY does not matter. AX, this is just a guess. If it's wrong, I can switch back later on. Okay, I'm just guessing. I don't know which direction. It's just a guess. Okay. So from here, I'm going to apply static analysis. Okay, we're going to apply static analysis. So when you apply static analysis, you have to draw your transformation. This is your X, this is your Y, this is the rotation about your Z. Okay, so I'm going to do summation of moment in the Z direction, and I'm going to do the moment analysis at point A. Okay, so I've chosen to take the moment at point A. Okay, so the equivalent load is going anti-clockwise. So it's equal to 60 times 10 to the power 3. The distance is 4. Now this is from point A. Okay, and then the next one is 25 times 10 to the power 3, the same direction, anti-clockwise. And then the distance is 6 plus 3 is 9. Okay, and then CD is 9, is going clockwise, minus 9 FCO, sorry. And then FBO is also going clockwise, and the distance is 6. So this is equal to 0. Okay, so we were now tally what is it. So this is 240 times 10 to the power 3 plus by 25 power 3 times 9 is equal to 3 power 3. 25 power 3 times 9 is equal to 225 times 10 to the power 3 minus by 9 FCD minus by 6 FBO. Sorry, CO, not CD. Okay, so you will have 250, 240 plus 225, 465. Okay, so you have 9 FCO plus by 6 FBO. The whole thing will be equal to 465 times 10 to the power 3. Okay, so this is our equation number 1. And then next we use our static analysis. Again, we do summation about forces in the X direction. Okay, in the X direction. So we have FCO, sorry, plus by FBO, okay, minus by 25 times 10 to the power 3, minus by 60 times 10 to the power 3, plus by AX is equal to 0. Okay. So FCO plus by FBO plus by AX is equal to 25 power 3 plus by 60 power 3 is 85 times 10 to the power 3. This is our equation number 2. Okay, and then finally, summation of forces in the y direction is equal to 0. So you have AY is equal to 0. Okay. So now we have a problem. Okay. Now we have a problem. So what this problem is we have is this. We have formed two equations. And we have what? 3 unknown. Okay. So we cannot solve just using static analysis. Okay. So what we like to call this structure is this structure. Okay, this structure is known as statically indeterminate. Right? So the structure is statically indeterminate. Okay. So we have to apply elastic deformation to solve elastic deformation of the cable which is our B naught and C naught, okay, to form another equation. Okay. We have no choice, or not, we cannot solve it. Okay, so we are going to now do a different sort of analysis, and it's not that difficult. Okay, it's simple. We're going to apply elastic deformation of the cable to find or to form another equation. Okay. So we look at the deformation. Okay, we look at deflection of point C. Let me get the diagram, then you can see better. Okay, let me copy and let me paste. You can see better when I write. So we want to find the deformation of point C, and deformation of point C is dependent on FC naught. Okay, so we just apply, and it's going to be in tensile, right? So FC naught the length is 2 meters divided by the area. So pi is 12 millimeters, 6 times 10 to the power minus 3 squared. And the Young's modulus is 200 times 10 to the power 9. Okay, and we know that it's going to be tension. Okay, so 2 divided by shift pi divided by 6 power minus 3 squared divided by 200 power 9 is equal to 88.419 positive is in tension, yeah? Positive 88.419, okay, times 10 to the power minus 9 FC naught. Okay, so this will be our equation number 3. And then deflection at point B is equal to FV naught multiply, now the length changed to 4 meters, right? Because the length of the cable is 4 meters. Divide by pi, same diameter, same material. Okay, so 4 divided by shift pi divided by 6 power minus 3 squared divided by 200 power 9. Okay, 4 divided by shift pi divided by 6 power minus 3 squared divided by 200 power 9 is equal to 176.83, positive 176.838 times 10 to the power of minus 9 FB naught. So this is our equation number 4. Okay. So the next thing, now we have like 4 equations. Okay. And we have 3 unknowns. However, this equation is not really good for us. Okay, because we cannot just take all this and put it into equation number 1. It will not work at all. Okay, because we don't know the deflection of at point C, we don't know the deflection at point B, but we can relate them. Okay, so the next thing that we have to consider is, do we have page? Oh, we have to relate deflection of point C and deflection of point B based on geometry analysis. So what do I mean by that? Based on geometric relationship. Okay, so that is where, remember, we assume, okay, we assume ABC to be rigid body, right? Okay, so now we're going to sketch the thing out again very quickly. So this is our beam, right? And this is where our point A is. Then somewhere up is our point B, and then there is our point C. Because we assume to be rigid body, the deformation will be the same. Okay, not the same, but the C prime and B prime will share the same gradient. Okay, and the distance from here to here is known as our deflection of point C, and our distance from here to here is our deflection at point B. Okay, so next we just need to form a gradient. Okay, gradient. So we know that B prime and C prime are on the same gradient. So how do we calculate this gradient? So gradient is equal to the change in Y over the change in X. Okay, So if you were to calculate the change in x is delta B, the distance from A to B is 4, right? And then this will be equal to the deflection at C, and the distance from A to C is what? Is equal to 6 plus, what is 6 plus, I'm looking for my question now. Is equal to 6 plus, wait, let's look at the question. Is equal to 6 plus 3, 9. Okay. So now we can form another equation.
Shouldn't the distance from A to B be 6?
Yeah, 6. Yeah, not 4. Yep, 6. Thank you. Okay. So from here we can from here we can form our next, we can substitute equation 3 and 4, right? Deflection of B. So this will be our equation number 4, and this will be our equation number 3, right? So I'm going to put everything in now. Okay, so 6 over deflection of B is equal to 176.838 times 10 to the power minus 9 F B naught, and this will be equal to 9 over equation C, which is 88.419. 88.419 times 10 to the power minus 9 F C naught. Okay. So now the deflection just cancel itself off. Now we have in terms of forces. Okay. So I'm going to have FCD is equal to 9 multiplied by 176.838 times 10 to the power minus 9, and FB naught divided by 6, and then divide by 88.419 times 10 to the power minus 9. Okay. So this will be equal to 9 divided by 6 and 176.838 power minus 9 divided by 88.419 power minus 9 is equal to 3. Okay, 3 FBD. So this will be our equation number 5. Okay, so we are almost done. So we're going to substitute equation 5 into our equation number 1. Okay, so equation number 1 is 9F CD C naught. Okay, not CD. 9F C naught plus by 6F B naught, and this will be equal to 465 times 10 to the power of 3. Okay, so it's 9 multiplied by 3FB naught plus by 6FB naught is equal to 465. Okay, so FB naught is equal to 465 times 10 to the power 3 divided by 9 times 3 is 27 plus 6 is 33. Okay, so 465 power of 3 divided by 33 is equal to 14.091 times 10 to the power 3 Newton. Okay, so therefore F CD is equal to 3 times of 14.091 times 10 to the power 3. Okay, so 3 times 14.091 power 3 is equal to 42.273 times 10 to the power 3 Newton. And the last part, okay, I know I'm half an hour over. I do apologize. So the last part, which is we already formed the equation, is the deflection at point C. Okay, So deflection of Poisson, we already formed the equation, okay? So we have F C naught multiplied by 88.419, okay, times 10 to the power minus 9. So where do we have this is we have it from here, okay? You can see this is from here, okay? And then finally, this will be equal to 42.273 times 10 to the power 3 multiplied by 88.419 times 10 to the power minus 9. Okay, so this will be equal to 42.273 power 3 times 88.419 power minus 9. It's equal to 3.737.
Sir, don't we have to multiply, divide by E and diameter as well to find deflection?
I did that already.
Okay, it's now other side. Okay, I see.
Okay, or 3.737 millimeter. Okay, and it's going towards the left. Okay, so this is as I said, this is a interesting question. It combines static analysis and elastic deformation. Okay, homework is posted, and I'll post your quiz on Monday. Okay, if that's the case, have a great weekend. Do your homework, and I'll see you next week. Okay, thank you. I'll still be around if you have any question. Let me stop recording first.
Thank you.